What if the oldest civilization on Earth didn't just remember the past, but calculated the future? What if those clay tablets buried beneath Iraqi sand contain more than records of ancient kings and forgotten gods? What if they contain a clock, still ticking, measuring something we've forgotten how to fear? In museum archives across the world, fragments of Sumerian mathematics rest behind glass. Numbers carved in base 60 that we still use to measure hours and degrees. Astronomical cycles so precise they match modern observations. And woven through it all, a pattern, a rhythm of catastrophe and renewal that repeats with mathematical certainty. The Sumerians called them the Great Returns. And if their calculations were correct, they weren't just documenting history, they were predicting ours. Before we go further, consider subscribing if you're drawn to the kind of history that refuses to stay buried. And if you're listening in the dark somewhere, leave a comment telling me where you are and what time you're keeping. I'd like to imagine this mystery unfolding across time zones as you drift towards sleep. Somewhere in the basement of the British Museum, long after the visitors have gone and the security lights have dimmed their nighttime hum, a curator sits alone with a clay tablet no larger than her palm. The room is climate-controlled, kept at precisely 65 degrees Fahrenheit with 45% humidity, conditions designed to preserve objects that have already survived 5,000 years of desert heat and flood and empire. She wears cotton gloves, though she has handled thousands of these tablets before, and still she pauses each time feeling the weight of the thing, not just its physical mass but the accumulated silence of millennia pressing into her fingertips. The tablet is covered in wedge-shaped marks, tiny impressions made by a reed stylus pushed into wet clay before it dried and hardened into something approaching permanence. If she tilts it toward the lamp, she can see where the ancient scribe corrected a mistake, smoothing over one set of marks and pressing new ones in their place. And at the edge, almost invisible unless you know to look, she can see the faint ridge of a thumbprint, preserved in the clay like a fossil belonging to someone who lived and worked and worried about deadlines 4,000 years before the pyramids of Giza were built. She is one of perhaps 300 people in the world who can read this script fluently, and even she admits that what she reads often raises more questions than it answers. This particular tablet records grain shipments, quantities of barley moving between temples and storage facilities in a city whose name we pronounce as Girsu, but whose inhabitants probably said something slightly different, a sound lost to the erosion of time. It is, in the grand scheme of Sumerian literature, utterly mundane, and yet it exists. It was made, it was stored, it was preserved, it was buried, it was found, and now it rests in her hands in a room that would have seemed like sorcery to the scribe who made it, and she cannot help but wonder why they wrote so much, why they recorded everything, why this civilization above all others in the ancient world seemed determined to press every transaction, every prayer, every observation into clay, and leave it for someone, anyone, to find. The numbers are staggering when you begin to count. Over 500,000 cuneiform tablets have been excavated from the ruins of ancient Mesopotamia, scattered now across museums and university collections in London and Berlin and Philadelphia, and Baghdad and Paris and New Haven. 500,000 fragments of ancient thought, and scholars estimate that perhaps only 10% have been fully translated and published. The rest wait in storage rooms and archive drawers, their secrets intact, their clay surfaces still holding whatever knowledge or trivia or revelation the scribes pressed into them 5 millennia ago. We could spend another century doing nothing but reading what the Sumerians left behind and still not finish. And what we have translated reveals a civilization that documented everything. There are tablets recording the sale of a single sheep, tablets listing the beer rations distributed to temple workers, tablets containing multiplication tables used to train young scribes, tablets preserving hymns to gods whose names we struggle to pronounce correctly, tablets recording the movements of Venus across the night sky with an accuracy that would not be matched again until the invention of the telescope, tablets containing legal disputes about property boundaries and inheritance rights and the proper compensation for a man who lost an eye in a fight, tablets with love poems and lullabies and proverbs warning against laziness and drunkenness, tablets with medical prescriptions specifying which plants to grind together for headaches and which prayers to recite while applying the paste, and tablets, so many tablets, devoted to calendars, to the tracking of days and months and years and cycles that seem to stretch far beyond any practical agricultural purpose. The Sumerians did not merely record, they recorded obsessively institutionally, with a fervour that suggests recording itself was a kind of sacred act, a duty that transcended the mundane content of any individual tablet. Consider what it takes to maintain a civilization of scribes. You need schools, which the Sumerians called a duba, the tablet house, where young boys spent years learning the complex cuneiform system, memorizing hundreds of signs, practicing on clay until their fingers ached. You need standardized training so that a tablet written in Ur can be read by a scribe in Nippur 200 miles away. You need bureaucracies to employ these scribes, to pay them, to house them, to give them work worthy of their skills. You need a cultural consensus that writing matters, that the effort of training and maintaining a literate class is worth the resources it demands. The Sumerians built all of this from scratch, created the first writing system complex enough to record abstract thought, and then they used it to record everything, everything, as though they were afraid that forgetting was the only true death. Other ancient civilizations wrote. The Egyptians covered their tombs with hieroglyphics, the Chinese inscribed oracle bones with questions for the ancestors, but none matched the Sumerian output. None approached the sheer volume and variety of what was pressed into clay in the river valleys between the Tigris and Euphrates. And hidden within that volume, scattered among the grain receipts and legal contracts and temple inventories, are tablets that suggest the Sumerians were tracking something far stranger than seasonal floods and harvest cycles. They maintained multiple calendars simultaneously, a complexity that still puzzles scholars who try to reconcile the different systems. There was a lunar calendar, tracking the moon through its phases, 12 months of 29 or 30 days that drifted slowly out of alignment with the solar year. There was a solar calendar, tracking the position of the sun relative to the stars, used for agricultural planning and religious festivals. There was a star calendar, noting which constellations rose at dawn at different times of year, used for navigation and perhaps for something else entirely. There was a king year calendar, dating events by the reign of the current ruler, creating a historical framework that stretched backward through generations. And there were intercalation systems, complex mathematical adjustments designed to synchronize these different calendars, to keep the lunar months aligned with the solar seasons, to prevent religious festivals from drifting into the wrong time of year. The mathematics required for these adjustments is not trivial. The Babylonians, heirs to Sumerian astronomical tradition, eventually developed intercalation cycles of 19 years, adding 7 extra months across that span to keep lunar and solar calendars synchronized. This is sophisticated calendrical science, the kind of precision that requires sustained institutional observation across centuries. But here is what makes it strange. Farmers do not need this level of precision. You do not need to track Venus across the sky to know when to plant barley. You do not need to reconcile lunar and solar calendars to know when the river will flood. Seasonal agriculture, the presumed purpose of all ancient calendars, requires only rough approximations, a general sense of which part of the year brings heat and which brings rain. The complexity of Sumerian timekeeping exceeds its practical purpose by an order of magnitude, as though they were tracking something else, something invisible to us, something that required precision across timescales that no single human lifespan could observe. And then there is the Sa. In the Sumerian mathematical system, which used base 60 rather than our base 10, the Sa represents 60 times 60, or 3,600. It is used as a unit of area, measuring land in squares of certain dimensions. But it also appears in the Sumerian king list, that strange document we encountered in the Hook, as a unit of Visan. The pre-flood kings ruled for periods measured in Sars, 8 Sar, 10 Sar, 12 Sar, in possibly long reigns that have puzzled scholars since the tablets were first translated. If you take the numbers literally, these kings ruled for 28,000 years, 36,000 years, 43,000 years. The total pre-flood period, according to some versions of the king list, adds up to 241,200 years. These numbers are absurd if read as literal lifespans. No human rules for 36,000 years. But they are not absurd if read as something else entirely. If the Sar represents not a lifespan but an epoch, a cosmic unit of time corresponding to some astronomical cycle, then the king list transforms from impossible history into possible chronology. The question is, what cycle, what astronomical phenomenon takes 3,600 years to complete? What were the Sumerians measuring, and why did they need a unit large enough to measure it? The deeper you dig into Sumerian records, the more this pattern emerges. A civilization obsessed with cycles, a calendar system designed for precision far beyond agricultural necessity, a mathematical unit that measures time in epochs of 3,600 years, and a cultural urgency around recording, preserving, transmitting knowledge that suggests they believe forgetting was not merely inconvenient but catastrophic. Most civilizations develop calendars to track seasons. The Sumerians developed calendars to track something that moved on timescales of millennia, something invisible within a single lifetime but visible, perhaps, across the accumulated observations of centuries. They were not watching the immediate sky, they were watching the slow sky, the gradual sky, the sky that shifts so imperceptibly that only institutions spanning generations could notice the change. And the question that hovers over every tablet, every fragment, every thumbprint pressed into clay 5,000 years ago is simply this. What were they counting toward? What event, what cycle, what return did they believe was coming? And did they calculate when it would arrive? In the Yale Babylonian collection, catalogued under the designation YBC 7289, there rests a small clay tablet roughly the size of a drink coaster, its surface covered with the wedge-shaped marks of cuneiform script surrounding a simple geometric diagram. The diagram shows a square with its two diagonals drawn, creating 4 triangles within the boundary. Along one side of the square, a number is inscribed in the sexagesimal notation the Sumerians used, and along the diagonal another number appears, and when modern mathematicians first examined this tablet and converted those ancient numerals into our decimal system, they found something that should not exist. The number along the diagonal is 1.4142126, which is the square root of 2 calculated to 6 decimal places, accurate to within 100,000th of the value your smartphone would give you today. This tablet dates to roughly 1800 BCE, created by a scribe in a Babylonian school that inherited its mathematical traditions from the Sumerians who came before. The Greek mathematician who would later prove the irrationality of the square root of 2, who would demonstrate that it cannot be expressed as a simple fraction and therefore extends infinitely without repeating, would not be born for another 1300 years. The iterative algorithm used to calculate this value on the tablet, a method of successive approximation that converges on the true answer through repeated refinement, matches the technique modern computers use to calculate square roots. And the tablet is not a mathematical treatise or a scholarly achievement meant for display. It is a school exercise, a practice problem, the ancient equivalent of homework, suggesting that this level of precision was so routine, so embedded in the educational system, that students were expected to produce it as a matter of course. We are not looking at the cutting edge of Sumerian mathematics. We are looking at what they taught children. The question that haunts every historian of mathematics who examines these artifacts is why? Why would a civilization that had recently emerged from the Neolithic, a civilization whose primary concerns should have been irrigation and grain storage and the management of livestock, develop a mathematical system capable of precision that would not be equalled in Europe until the Renaissance? The answer may lie in a peculiar choice the Sumerians made at the very foundation of their numerical system, a choice that separates their mathematics from every other ancient tradition, and that embeds a specific purpose into the structure of counting itself. They chose base 60. We count in base 10, almost certainly because we have 10 fingers and our earliest ancestors counted on their hands. The Maya counted in base 20, probably because they counted fingers and toes together. The Babylonians and Egyptians eventually developed base 10 systems of their own, but the Sumerians, from the earliest records we possess, counted in base 60, a choice so unusual that scholars have debated its origins for over a century without reaching consensus. Some suggest it emerged from combining a base 5-finger counting system with a base 12 system used by merchants, but this explanation feels inadequate to the mathematical elegance that results, because 60 is not merely a large number. 60 is the smallest number divisible by 1, 2, 3, 4, 5, and 6. It is also divisible by 10, 12, 15, 20, and 30. No smaller number possesses so many divisors, and this property, this exceptional divisibility, makes base 60 uniquely suited for one particular application: the calculation of fractions and cycles. When you divide a circle into 360 degrees, a number chosen because it is 60 times 6 and therefore shares the divisibility properties of its base, you can express angles in clean fractions. A right angle is 90 degrees, exactly 1/4 of the circle, A third of a circle is 120 degrees. A sixth is 60 degrees. The fractions resolve cleanly without the endless decimals that plague base 10 calculations. And when you're tracking cycles, when you're calculating how many days until the planet returns to the same position, when you're predicting when the moon will eclipse the sun again, clean fractions are not a luxury. They are the difference between precision and error, between calendars that work and calendars that drift. Consider what we still carry from this choice. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These are not natural units derived from physical observation. There is nothing in nature that cycles in 60s. These are Sumerian units, embedded so deeply in our measurement of time and space that we have forgotten they were ever a choice at all. When a modern astronomer calculates the position of a satellite, when a navigator plots a course across the ocean, when a pilot reads the instruments in a cockpit, they are using a mathematical framework invented in the river valleys of Mesopotamia 5,000 years ago, preserved through the Greeks and Arabs and medieval Europeans who recognized its elegance even when they had forgotten its origins. The Sumerian system did not survive because it was simple. It survived because it was specifically optimized for tracking cycles in the heavens, and no one has ever devised a better system for that purpose. We are still speaking their mathematical language every time we check the clock or measure an angle, and the language encodes its purpose in its structure. This was not a system designed for counting sheep or measuring grain. This was a system designed for calculating when celestial events would recur. The precision of Sumerian astronomical records confirms this interpretation. In the British Museum there exists a series of tablets known collectively as the Venus tablets of Amisaduqa, named for the Babylonian king during whose reign they were compiled from older sources. These tablets record the rising and setting of Venus over a period of 21 years, noting exactly which day the planet appeared in the morning sky and which day it disappeared, tracking the full cycle of what astronomers call the synodic period of Venus. The value recorded on these tablets is 584 days, the time it takes for Venus to return to the same position relative to Earth and the Sun. This matches the modern calculated value with perfect accuracy. It is not an approximation. It is not rounded. It is exact, derived from observations so careful and so sustained that they captured a cycle most people never notice, a cycle that requires watching the pre-dawn sky for years on end and recording every appearance and disappearance with meticulous attention. Who performed these observations? The tablets do not say, they simply present the data as established fact, as knowledge so foundational that its derivation no longer needed explanation, and Venus was only the beginning. Sumerian and Babylonian astronomers tracked Mercury, Mars, Jupiter, and Saturn with comparable precision. They recorded eclipses and predicted future ones. They developed mathematical models for planetary motion that could forecast positions years in advance. They understood that the heavens moved in cycles, that what had happened before would happen again, and they built a mathematical infrastructure specifically designed to calculate when. Even more unsettling is the tablet known as Plimpton 322, housed at Columbia University, a document that contains what appears to be a systematic list of Pythagorean triples, sets of three numbers that satisfy the relationship where the square of one number plus the square of another equals the square of a third. The relationship we call the Pythagorean theorem, the foundation of trigonometry and surveying and navigation, appears on this tablet roughly 1,000 years before Pythagoras was born. The numbers are arranged in columns with a precision that suggests not just knowledge of the theorem, but systematic exploration of its possibilities, a kind of mathematical table that would not be reproduced in Western tradition until modern times. Scholars still debate the exact purpose of Plimpton 322, whether it was a teaching tool or a reference table or something else entirely, but the mathematical sophistication it demonstrates is beyond dispute. The Sumerians and their Babylonian successors were not fumbling toward mathematical understanding. They possessed a complete and coherent system capable of calculations we would have sworn required Renaissance or even modern methods, and they possessed it from the earliest records we have been able to recover. The developmental period, the centuries of trial and error that should have preceded such sophistication, has left no trace. Either it occurred somewhere else, in some earlier context we have not yet discovered, or the knowledge was transmitted to the Sumerians from a source we do not yet understand. Perhaps the most profound implication of this mathematical system is what it reveals about Sumerian intentions. If you wanted to preserve knowledge across a catastrophe, If you knew that languages change and cultures collapse and libraries burn, what would you use as your storage medium? Words are fragile. They require speakers who know their meanings, scribes who can write them, readers who can interpret them. A single generation of disruption can sever the chain of transmission and leave inscriptions unreadable. But numbers are different. Numbers do not depend on language. The relationship between 3 and 4 and 5, the fact that 3 squared plus 4 squared equals 5 squared, is true regardless of what sounds you use to express it. A base 60 system encodes its own usage in the structure of its divisibility. A circle divided into 360 degrees demonstrates its own mathematical logic to anyone who examines it carefully. If the Sumerians were trying to preserve astronomical knowledge in a form that could survive translation, survive conquest, survive even the forgetting of their language, mathematics would be the obvious choice. The numbers themselves become the memory, carrying information not in their content alone, but in their structure, in their relationships, in the elegant divisibility that makes certain calculations possible. We are still using their system because it works, because its design contains its own justification, because anyone who tries to track celestial cycles will eventually discover that base 60 makes the calculations cleaner. The mathematics is not merely a tool, the mathematics is a message, and the message is that someone, somewhere, cared very much about calculating when cycles would return. This brings us to the heart of what the Sumerians were doing with all this precision. Their astronomical tablets do not merely record where planets are, they record when configurations will recur. They track conjunctions, moments when 2 planets appear to meet in the sky. They track oppositions, moments when a planet appears directly opposite the Sun. They calculate how many days or months or years must pass before a particular arrangement of celestial bodies will repeat. This is not astronomy in the modern sense, dispassionate observation of physical phenomena. This is astronomy with a purpose, astronomy oriented toward prediction. Astronomy that assumes the future will resemble the past because the heavens move in cycles and what goes around comes around. And if your mathematical system is built specifically for cycle calculation, if your astronomical records are focused specifically on recurrence, if your entire intellectual infrastructure seems designed to answer the question of when something will happen again, then you are not merely recording history. You're constructing prophecy. You're using the past to calculate the future. You're building one clay tablet at a time, a machine for predicting what comes next. And the question that emerges from this mathematical evidence, the question that will haunt us through the remainder of this story, is what exactly the Sumerians believed was coming. What cycle were they tracking with such care? What return were they calculating toward? And when, according to their mathematics, did they expect it to arrive? In the Ashmolean Museum at Oxford, protected behind climate-controlled glass in a room where footsteps echo against marble floors, there stands a 4-sided clay prism roughly 8 inches tall. Its surface is densely covered with cuneiform text arranged in neat columns that wrap around all 4 faces. This is the Weld Blundell prism, named for the collector who acquired it in 1922, and it contains one of the most complete surviving copies of a document scholars call the Sumerian King List. The prism was designed to be rotated, each face presenting a continuation of the same long chronicle, a single narrative that begins with a declaration we have already encountered, and then proceeds through name after name, city after city, reign after reign, stretching backward through time, until the numbers themselves break apart into something that no longer resembles human history. The scribe who created this object around 1800 BCE was not composing original material. He was copying, preserving a document that was already ancient in his day, a text that had been transmitted through generations of careful reproduction because someone, somewhere, had decided it must not be lost. The clay is the colour of dried riverbed, a pale tan that catches the museum lighting and throws the wedge-shaped impressions into sharp relief. If you lean close to the glass, close enough that your breath begins to fog the surface, you can see where the scribe pressed his stylus with varying pressure. Deeper marks for certain signs, lighter touches for others, a rhythm of inscription that speaks to years of training and practice. He was good at his job, he made very few errors, and he recorded, with the same bureaucratic precision used for grain shipments and temple inventories, a list of kings whose reigns add up to nearly 250,000 years before the flood, and whose post-flood successors gradually shrink from impossible millennia to merely improbable centuries to finally, at the end of the document, reign lengths that match what archaeology can confirm. The question is not whether this document is strange, the question is what kind of strange it is. The structure divides cleanly into two sections separated by a single sentence that changes everything. The pre-flood section lists 8 kings ruling in 5 cities: Eridu, Bad Tibira, Larak, Sippar, and Shuruppak. Each king is assigned a reign length measured in a unit called the SAR, though the numbers are presented in their full form rather than abbreviated. Alulim of Eridu ruled for 28,800 years. His successor Alalgar ruled for 36,000 years. The kingship then moved to Bad Tibira, where Enmenluana ruled for 43,200 years, followed by Enmengalana for 28,800 years, and Dumuzi for 36,000 years. At Larak, Ensapadzidana ruled for 28,800 years. At Sippar, Enmedurana ruled for 21,000 years. And finally at Shuruppak, Ubara Tutu ruled for 18,000 years before the document delivers its devastating pivot. Then the flood swept over. After that sentence, kingship descends from heaven again, this time to the city of Kish, and the numbers begin to shrink. The first post-flood king still rules for an impossible 200 years. His successors manage 960 years, 670 years, 420 years. By the time the list reaches kings whose existence can be verified through independent archaeological evidence, the reigns have contracted to decades, to the span of actual human lifetimes. The document presents this progression without comment, without distinguishing the impossible from the plausible, treating the 43,200-year reign of Enmenluana with the same flat bureaucratic tone it uses for the 12-year reign of a king whose seal impressions we have found in the ruins of Ur. Whatever the king list is, it does not consider itself mythology. It considers itself record. The mathematical patterns in the pre-flood section are too precise to be accidental. When you convert the reign lengths from their full numerical expression into multiples of the SAR unit of 3600 years, the structure reveals itself. Alulim ruled for 8 SAR, Alalgar ruled for 10 SAR, Enmenluana ruled for 12 SAR, Enmengalana ruled for 8 SAR, Dumuzi ruled for 10 SAR, Ensapadzidana ruled for 8 SAR. The numbers cluster around multiples of 300 with a consistency that cannot emerge from random invention or garbled memory. If you were making up numbers to aggrandize ancient kings, you would expect more variation, more arbitrary magnitudes, the kind of creative exaggeration that produces claims of living for 1,000 years or 10,000 years, without mathematical pattern. But the Sumerian king list does not exaggerate randomly. It encodes systematically. Every pre-flood reign length is either an exact multiple of 3600 or a number that fits cleanly into the sexagesimal system that underlies all Sumerian mathematics. This is not mythology dressed as history, this is mathematics dressed as mythology. Numbers hiding behind names. A code that reveals itself only when you stop reading the document as biography and start reading it as calculation. The total pre-flood period, when you add all 8 reigns together, comes to 200 years. This number has attracted the attention of researchers interested in astronomical cycles because it is not arbitrary either. The precession of the equinoxes, the slow wobble in Earth's axis that causes the position of the Sun at the spring equinox to drift backward through the zodiac constellations, takes approximately 25,920 years to complete a full cycle. This is not a phenomenon visible within a human lifetime. The precessional shift amounts to roughly 1 degree every 72 years, a drift so gradual that only sustained institutional observation across centuries could detect it. Yet the ancient world knew about precession. The Greek astronomer Hipparchus is traditionally credited with its discovery in the 2nd century BCE, but evidence suggests that earlier civilizations, including the Babylonians who inherited Sumerian astronomical traditions, were aware of the phenomenon long before. If you divide 241,200 by 25,920, you get 9.3, meaning the total pre-flood period represents approximately 9 1/3 precessional cycles. This could be coincidence. It could be numerological pattern matching imposed by modern researchers eager to find meaning. But it could also be evidence that the Sumerian king list encodes precessional time, that the impossible reign lengths are not meant to describe human lifespans at all, but rather to mark cosmic epochs, vast cycles of celestial motion measured in the only units large enough to contain them. This interpretation transforms the king list from impossible history into possible astronomy. If kingship does not mean a human ruler, but rather the celestial configuration that governs an era, then the statement that kingship descended from heaven takes on new meaning. Each king becomes not a person but a period, an age defined by the position of stars and planets, a unit of cosmic time marked by the dominance of certain celestial patterns. The cities where kingship rested become not political capitals, but astronomical stations, markers in a cycle of celestial sovereignty that rotates through positions the way the equinox sun rotates through zodiac constellations. Eridu, Bad Tibira, Larak, Sippar, Shurapak. Not places where individual humans held power, but phases in a cosmic calendar, each one associated with a particular duration, a particular count of SRs, a particular segment of the Great Wheel turning through deep time. The flood in this reading is not merely a catastrophe but a transition, the moment when one cosmic era ended and another began, a reset that closed the pre-flood cycle of 241 years and opened the post-flood cycle in which the rains gradually contract as we approach the historical present. The king list becomes not a genealogy but a clock, a timepiece measuring intervals too vast for human lifespans to perceive, encoding its measurements in the language of dynasty because that was the language the culture understood. The phrase that follows the flood description supports this interpretation in ways that become more striking the more closely you examine them. The standard translation reads, "After the flood had swept over, and the kingship had descended from heaven, the kingship was in Kish." But notice the structure. Kingship descends from heaven again. This is not a unique event, not a singular divine intervention, but a recurrence, a restoration of something that had existed before and was interrupted. The language implies that the descent of kingship is a repeatable phenomenon, that what happened at Eridu before the flood happened again at Kish after the flood, that the cosmic mechanism remains intact even when catastrophe disrupts its earthly manifestation. If you read the king list as astronomical chronology, this makes perfect sense. The celestial cycles continue regardless of what happens on Earth. The precession keeps processing. The planets keep orbiting. The conjunctions and oppositions keep recurring on their mathematically predictable schedules. A flood might destroy cities and drown populations, but it cannot stop the heavens from turning. When the waters recede and civilization rebuilds, it rebuilds under the same sky, governed by the same cycles, subject to the same cosmic clock that was ticking before the catastrophe and will continue ticking long after. Kingship descends from heaven again because heaven never stopped turning. This raises a question that cuts to the heart of why the Sumerians might have encoded their knowledge this way. If the king list is a cosmic calendar disguised as a genealogy, what purpose does the disguise serve? Why not simply write an astronomical treatise, a straightforward account of celestial cycles measured in SARs and precessional periods? One answer might be survival. A genealogy survives because it serves ongoing political purposes. Later kings trace their legitimacy through connection to earlier kings. Scribes copy the list because the list matters to the people in power. An astronomical treatise, by contrast, survives only if someone cares about astronomy, and intellectual priorities shift with civilizations. By encoding their cosmic chronology in the language of kingship, the Sumerians ensured that subsequent cultures would preserve the document even if they forgot what the numbers actually meant. The Babylonians who copied the king list and the Assyrians who maintained their own versions were preserving their royal heritage, their political legitimacy, their connection to ancient authority. They may not have known they were also preserving an astronomical record, a cosmic clock still ticking beneath the surface of the genealogical narrative. The encoding was the protection. The mythology was the camouflage. The numbers survived because they looked like something else. Another answer might be warning. If the Sumerians believed that catastrophe was cyclical, that floods and devastations recurred on schedules that could be calculated, then the calculation itself would be valuable beyond measure. But valuable knowledge is dangerous knowledge. It can be suppressed, destroyed, and monopolized by those who want to control its implications. By encoding the warning in a genealogy, by distributing it through copies that served other purposes, the Sumerians created a decentralized archive. The king list exists in multiple versions, found in multiple cities, preserved in multiple museums. If one copy is destroyed, others survive. If one culture forgets what the numbers mean, another might remember. The warning persists even when the understanding of the warning does not, waiting for someone to look at the pattern, to notice the multiples of 3600, to ask why the pre-flood period adds up to 9 precessional cycles, 2. Wonder what cosmic event the Sumerians were tracking so carefully and whether that event might recur. The king list might be a time capsule, a message buried not in the ground, but in the structure of numbers, waiting millennia for readers sophisticated enough to decode it. And if this interpretation is correct, then the message the Sumerians were sending is clear. The flood was not the end. The flood was part of a cycle, and cycles by definition come around again. The question is not whether the reset will happen. The question is when. And the Sumerians, with their base 60 mathematics and their SAR units and their impossible king reigns, were trying to tell us exactly that. They were trying to give us the date. In the winter of 1929, the British archaeologist Leonard Woolley stood at the bottom of a deep excavation trench in the ruins of ancient Ur, staring at something that made no sense. His team had been digging for months, cutting down through layer after layer of occupation debris, the accumulated detritus of thousands of years of human habitation, pottery shards and ash deposits and collapsed mud brick walls compressing into stratified bands that told the story of the city's long history. They had passed through the royal cemetery with its spectacular treasures, through earlier occupation levels dating back millennia, and they had expected to continue finding traces of human activity until they reached the virgin soil beneath the city, the natural clay that predated all settlement. Instead, they hit a layer of clean silt. It was perfectly uniform, pale and sterile, containing no pottery, no charcoal, no bone fragments, no evidence whatsoever of human presence. Woolley's first assumption was that they had reached the bottom, that this was the original riverbed clay upon which the first settlers had built. But something nagged at him, a reluctance to accept so neat an answer, and he ordered his workers to keep digging. They dug through 2.5 meters of this sterile deposit, 8 feet of clean water-laid sediment that had no business being there, and then the artifacts resumed. Beneath the silt layer, they found more pottery, more tools, more traces of human occupation, older styles and different techniques, but unmistakably the remains of a settlement that had existed before something catastrophic had happened, before something had deposited 8 feet of flood sediment and buried an entire world beneath clay. Woolley climbed out of the trench and reportedly said to his wife, who was working on the excavation, that they had found evidence of the flood. Not a flood, but the flood, the one recorded in the tablets, the one that divided the king list into before and after, the one that had swept over and required kingship to descend from heaven again. The archaeology confirmed what the texts had claimed all along. The flood was real. The same deposit appears at other Sumerian sites with remarkable consistency. At Shuruppak, the city, where the flood hero Ziusudra supposedly ruled before the waters came, excavators found a similar layer of flood silt separating earlier occupation from later reconstruction. At Kish, another major Sumerian centre, the pattern repeated, a sterile band of water-deposited clay marking an interruption in the archaeological sequence. At Eridu, where the king list says kingship first descended from heaven, the evidence of catastrophic flooding appears in the stratigraphic record. The dates cluster around 2900 BCE, give or take a few centuries depending on the excavation and the dating method employed, placing the event roughly at the transition between the early dynastic period and the preceding eras. This was not a global flood in the literal sense, not water covering every mountain on Earth as later traditions would elaborate, but within the boundaries of Sumerian experience, within the flat riverine plain where these cities stood, it might as well have been total. The Tigris and Euphrates can still produce catastrophic floods when conditions align. When snowmelt in the mountains coincides with heavy spring rains, when the channels shift and overflow their banks across a landscape with almost no topographic relief to contain the spread. A flood severe enough to deposit 8 feet of silt across a wide region would have destroyed every city, drowned every field, killed every person who could not reach high ground or a sturdy vessel. For the survivors, watching the waters rise over everything they knew, it would have seemed like the end of the world. Because for them, it was. The Sumerian flood narrative, preserved in fragments that predate all other versions by many centuries, follows a structure that has become so familiar we no longer notice how strange it is. A god, in this case Enki, the lord of wisdom and fresh water, learns that the divine assembly has decreed the destruction of humanity. He cannot openly defy the decree, so he speaks not to his favoured servant directly, but to a wall to a reed hut, knowing that Ziusudra will overhear. He gives instructions: build a vessel, seal it with pitch, bring aboard the seed of all living things. The flood comes, the waters rise, the world drowns. After 7 days and 7 nights the storm subsides, the vessel comes to rest, the survivor emerges and makes offerings. The gods, realizing what they have lost, relent. Civilization begins again. This narrative pattern repeats with variations across nearly every ancient culture we have studied. The Babylonian version in the Atrahasis epic adds detail about why the gods decreed destruction. Humanity had become too numerous and too noisy, disturbing divine rest. The later version embedded in the Epic of Gilgamesh names the hero Utnapishtim and adds the detail of releasing birds to test whether the waters have receded. The Hebrew Genesis account, compiled centuries later but drawing on Mesopotamian traditions, names the hero Noah and extends the duration of the flood to 40 days and nights, then 150 days before the waters fully subside. But the structure remains constant: divine warning, prepared survival, catastrophic deluge, eventual restoration. The story adapts to different theologies and cultural contexts, but its skeleton persists. What strikes researchers who study these narratives comparatively is not merely that the story appears across the ancient Near East, where cultural contact and textual transmission could explain the similarities, but that structurally identical tales appear in cultures separated by oceans and millennia, with no plausible connection to Mesopotamian tradition. The Hindu Pralaya describes cosmic dissolution through water at the end of each age, with the god Vishnu warning the first man Manu to build a boat and preserve the seeds of future creation. The Greek tradition of Deucalion tells of Zeus flooding the earth to destroy a corrupt humanity, with the hero and his wife surviving in a chest and repopulating the world by throwing stones that become people. The Aztec and Maya codices describe multiple world ages, at least one of which ended in catastrophic flooding before the current era began. The Chinese traditions speak of a great flood in the time of Emperor Yao, controlled eventually by the engineer Yu, whose efforts to drain the waters established the foundations of civilization. The Australian Aboriginal stories tell of a great flood in the Dreamtime that shaped the landscape and established the relationships between peoples and places. The Native American traditions across both continents contain flood narratives with striking structural similarities to the Mesopotamian original. Warning: preparation, survival, restoration. We can explain some of this as diffusion, as stories travelling along trade routes and migration paths, but we cannot explain all of it. Not the structural consistency across cultures that never contacted each other. Not the presence of flood myths in inland populations and coastal populations alike. Not the persistence of the pattern across every inhabited continent. Something else is at work. One possibility is that the flood myths record not a single event but a category of events. Not the flood, but floods. Recurring catastrophes that different cultures experienced at different times, but remembered using similar narrative templates because the experience itself was similar. Water rises, the world drowns, survivors rebuild. If you live through such an event, you tell the story. Your children tell the story. Your grandchildren elaborate the story. Eventually the story becomes sacred, becomes foundational, becomes the explanation for why the world is the way it is. Every culture that experienced catastrophic flooding, whether from rivers or tsunamis or glacial lake outbursts or rising sea levels at the end of ice ages, would develop flood mythology, because flood mythology is what happens when cultural memory tries to process survival. The consistency would reflect not a single shared source, but a shared type of experience, a parallel evolution of narrative in response to parallel trauma. This explanation has merit, but it does not fully account for the specific structural elements that repeat: the divine warning that allows preparation, the vessel that preserves life and knowledge, the birds released to test conditions, the offerings made upon safe landing. These are not obvious or inevitable elements of a flood survival story. They suggest a template, a pattern, perhaps even instructions. The Sumerian framing is particularly interesting because it refuses to treat the flood as unique. The king list does not present the deluge as a one-time rupture in cosmic order, but as a transition point in an ongoing cycle. Kingship existed before the flood. Kingship descended from heaven again after the flood. The word again carries enormous weight. It implies that the descent of kingship is a repeatable phenomenon, that the pre-flood world was itself a restoration from some earlier state, that the post-flood world will continue according to the same patterns that governed what came before. If the flood were truly singular, truly unprecedented, The language would reflect that singularity, but it does not. The flood swept over, kingship descended again, and the cycle continued. This framing suggests that the Sumerians understood catastrophe not as an aberration, but as a feature, not as a violation of cosmic order, but as part of cosmic order, a predictable interruption built into the structure of time itself. They were not surprised by the flood. They were prepared for the flood, and if the flood was part of a cycle, then the cycle could be calculated, and if the cycle could be calculated, then the next transition point could be anticipated. Modern science has begun to vindicate this intuition in ways the Sumerians could not have articulated, but might have understood. We now know that Earth experiences cyclical catastrophes on multiple timescales. The Milankovitch cycles, variations in orbital eccentricity, and axial tilt that occur over periods of roughly 26,000, 41,000 and 100,000 years, drive ice ages and interglacials, reshaping coastlines and climate patterns in ways that would have been catastrophic for any civilization in their path. The rising seas at the end of the last ice age, when global sea levels rose over 100 meters between roughly 15,000 and 6,000 years ago, drowned coastlines worldwide, submerging any settlements that had existed along the Pleistocene shores. Impact events, asteroids and comets striking the Earth, follow statistical patterns that suggest major impacts occur at predictable intervals when measured across geological time. Supervolcanic eruptions like the Toba event, roughly 74,000 years ago, or the more recent Tambora eruption that caused the year without a summer in 1816, recur at intervals that can be studied if not precisely predicted. The question is not whether catastrophes recur, they demonstrably do. The question is whether pre-industrial civilizations, through careful observation sustained across many generations, could have recognized the patterns and attempted to calculate the timing. If the Sumerians did recognize the cyclical nature of catastrophe, then their obsession with recording, with copying texts, with preserving knowledge in durable form, suddenly makes a different kind of sense. They were not merely bureaucrats documenting grain shipments, they were survivalists preparing for the next reset. Every tablet copied was a hedge against destruction. Every astronomical observation recorded was a data point that might help future generations recognize the signs. Every mathematical formula preserved was a tool that would be needed when the waters receded and civilization had to be rebuilt. The flood stories themselves, repeated and elaborated and transmitted across generations, were not merely cultural heritage. They were survival manuals, templates for how to recognize the warning signs, how to prepare, how to preserve what matters, how to begin again. The Sumerians had lived through a catastrophe. They had inherited memories of catastrophes before that one, and they believed, based on their observations of cosmic cycles, that catastrophe would come again. Their entire civilization, viewed through this lens, becomes a single sustained effort to prepare for the next flood, to ensure that knowledge would survive, to give their descendants, whoever and wherever they might be, a fighting chance. The clay tablets were not records of the past, they were messages to the future, and the message was simple. This has happened before, it will happen again, and here is what you need to know. In the collection of the Vorderasiatisches Museum in Berlin, there exists a small cylinder seal carved from lapis lazuli, roughly 4,000 years ago, its deep blue surface incised with figures and symbols that were meant to be rolled across wet clay to leave an impression marking ownership or authorization. Most cylinder seals depict scenes of worship or combat or mythological narrative, the visual vocabulary of Sumerian religious and political life. But this particular seal shows something different. Above the human and divine figures engaged in their ritual activities, the carver has included a band of celestial imagery, dots arranged in patterns, crescents and circles representing the moon and sun, and among them a configuration of marks that scholars have identified as the Pleiades star cluster, rendered with enough accuracy that the pattern is immediately recognizable to anyone who has looked up at the winter sky. This was not decoration, this was information. The seal owner was marking his documents with astronomical knowledge, embedding celestial data into the mundane transactions of daily commerce, as though the stars and the grain shipments and the temple offerings were all part of the same integrated system. And they were. For the Sumerians, the movements of heaven and the affairs of earth were not separate domains but interlocking gears in a single cosmic machine, each one affecting the other, each one readable by those who knew how to look. The cylinder seal is a small artifact, easily overlooked, but it represents something profound, a civilization that saw the sky not as a canopy of distant lights, but as a calendar, a clock, and perhaps a warning system, all encoded in the patterns of celestial motion. The Venus tablets of Amisaduqa represent the most sustained astronomical observation program that survives from the ancient world. Named for the Babylonian king during whose reign they were compiled, though drawing on observational traditions that stretched back centuries into the Sumerian era, these tablets record the appearances and disappearances of Venus over a continuous period of 21 years. The data is remarkably specific. On this date, Venus appeared in the eastern sky before dawn. On this later date, it disappeared into the sun's glare. On this subsequent date, it reappeared in the western sky after sunset. The observations continue month after month, year after year, tracking the planet through its complete synodic cycle, the time it takes to return to the same position relative to Earth and the Sun. The value the tablets yield is 524 days, and this number matches modern calculations with perfect accuracy. But what makes the Venus tablets truly significant is not just their precision, but their purpose. The Sumerians and Babylonians did not track Venus out of idle curiosity. They tracked Venus because Venus was the celestial manifestation of Inanna, the goddess of love and war, the queen of heaven, and her movements through the sky were omens that foretold events on Earth. When Venus rose as the morning star, it portended one set of outcomes. When it rose as the evening star, the portents differed. The specific position of Venus relative to other celestial bodies, relative to the zodiac constellations, relative to the dates of the calendar, all generated meaning, all could be read by those trained in the scribal arts. The astronomical precision served the omen system, and the omen system served something deeper. The conviction that the heavens and the earth were connected, that celestial patterns prefigured terrestrial events, that if you could read the sky correctly, you could know what was coming. The same logic drove Sumerian interest in planetary conjunctions, those moments when two or more planets appear to meet in the sky as seen from Earth. Jupiter and Saturn, the two largest planets visible to the naked eye, come into conjunction approximately every 20 years, a cycle called the Great Conjunction that has fascinated astronomers and astrologers for millennia. But the cycle is not perfectly regular. The conjunctions occur at slightly different points in the zodiac each time, rotating through the 12 signs over a period of roughly 800 years before returning to approximately the same position. Grand conjunctions, when Jupiter and Saturn meet in the same part of the sky as other planets, occur at even longer intervals, creating celestial configurations so rare that observing one would have been an event of enormous significance. Sumerian astronomical records track these conjunctions with evident care, noting when planets meet, in which constellation the meeting occurs, what other celestial conditions accompany the event. The omen texts associated with conjunctions are extensive, detailing what will follow when Jupiter meets Saturn, what will follow when Mars joins the meeting, what will follow when the conjunction occurs in certain houses of the zodiac. To modern eyes trained to see astronomy and astrology as separate domains, this mixing of observation and prediction seems confused, a failure to distinguish science from superstition. But to the Sumerians there was no confusion. The observation was the prediction. The celestial event was the cause. The terrestrial event was the effect. They were reading reality correctly, or so they believed, and the astronomical precision was in service of practical prophecy. The concept that haunts Sumerian and Babylonian astronomical thought is what later cultures would call the Great Year, a cosmic cycle so vast that it contains all lesser cycles within it, a period after which the entire celestial configuration returns to its starting point and the universe begins again. Different traditions calculated this period differently. The Greeks, inheriting Mesopotamian astronomical knowledge through Persian intermediaries, spoke of a great year that completed when all the planets returned to the same relative positions they had occupied at some original moment. The number most commonly associated with this concept in Sumerian and Babylonian sources is 432,000 years, a span that appears in multiple contexts with a consistency that suggests it was not arbitrary. This number is 20 SAR, on 20 units of 3600 years, fitting perfectly into the sexagesimal framework that underlies all Sumerian mathematics. It is also remarkably close to certain astronomical periodicities when you begin to calculate the lowest common multiples of planetary cycles, the time it would take for all the visible planets to return to approximately the same configuration. Whether the Sumerians derived this number from actual calculation, from inherited tradition, or from some combination of both, they clearly believed that cosmic time operated on a scale of hundreds of thousands of years, that the cycles they observed in Venus and Jupiter and Saturn were themselves embedded in larger cycles, and that these larger cycles had beginnings and endings with consequences for the world below. The Great Year was not merely a theoretical construct, it was a framework for understanding where in cosmic time the present moment stood, how far the whole cycle had progressed, and how long remained before the wheel turned fully and something fundamental changed. The question that emerges from this astronomical framework is whether the Sumerians believed specific catastrophic events were tied to specific points in the cycle. Modern science has increasingly recognized that certain celestial configurations do correlate with terrestrial effects, though not through the mystical causation the ancients imagined. The Earth passes through regions of space where debris from ancient comets accumulates, and the timing of these passages is cyclical. Asteroid belts have resonance patterns with planetary orbits that make impacts more likely at certain intervals than at others. The gravitational interactions between Jupiter and Saturn, when they align in certain configurations, can perturb the orbits of smaller bodies in ways that increase the likelihood of objects being deflected toward the inner solar system. None of this validates ancient astrology in any mystical sense, but it does suggest that the intuition underlying the omen literature, the conviction that celestial configurations correlate with terrestrial events, was not entirely unfounded. If the Sumerians had observed over many generations that certain planetary arrangements coincided with floods or famines or other disasters, they would have had empirical grounds for their predictions even if they misunderstood the causal mechanism. The omen texts would then represent not superstition, but pattern recognition, not mysticism but statistics, a record of correlations observed across centuries of careful watching, even if the watchers could not explain why the correlations held. The ziggurats themselves may have served this watching function in ways that archaeology is only beginning to appreciate. These massive stepped structures, rising from the flat Mesopotamian plain like artificial mountains, were aligned to the cardinal directions with a precision that required sophisticated surveying knowledge. The ziggurat of Ur, the best preserved of the surviving examples, shows deviation from true north of less than 1 degree, an accuracy that demands careful astronomical observation since the cardinal points can only be determined by tracking the movements of stars and sun. The 7 tiers of the classic ziggurat form, though not all ziggurats had exactly 7 levels, correspond to the 7 celestial bodies visible to the naked eye: Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. The high temple at the summit, accessible only to priests, provided an unobstructed view of the entire sky, a platform for observation elevated above the dust and haze that would have limited visibility at ground level. We tend to think of ziggurats as temples, as places of worship, and they were certainly that, but they may also have been observatories, instruments for tracking the slow motions of planets across the zodiac, for recording conjunctions and oppositions, for maintaining the sustained observation program that the Venus tablets demonstrate must have existed. The religious function and the astronomical function were not separate. They were identical. To watch the stars was to read the will of the gods. To record the movements of Venus was to document the moods of Inanna. The ziggurat was both temple and telescope, a structure designed to facilitate communion with powers that express themselves through celestial motion. The omen literature that survives from Mesopotamian archives is vast, numbering in the tens of thousands of individual predictions, catalogued and organized by celestial condition. If Venus rises in such a position relative to the Moon, then such an outcome will follow. If Jupiter is visible in such a constellation at such a time, then the king should expect such an event. If an eclipse occurs on such a date, in such a manner, then the land will experience such a fate. Modern scholars have tended to dismiss this literature as superstition, as the ancient equivalent of newspaper horoscopes, entertaining perhaps but meaningless. Yet the sheer scale of the enterprise suggests otherwise. Maintaining an omen archive of this size required enormous institutional investment, generations of scribes recording observations and outcomes, comparing predictions to events, refining the associations over time. You do not pour this level of resources into a system that does not deliver value. Either the Mesopotamian elites were systematically deluded for millennia, or the omen system worked in some sense, or at least worked often enough to justify the effort. If the omens encoded real observed correlations, even correlations whose underlying mechanism remained mysterious, they would have constituted a form of technology, a predictive technology, a system for anticipating events based on celestial configurations that had preceded similar events in the past. The language is mythological, the method is empirical, and somewhere in that vast archive of omens, perhaps, lies the warning the Sumerians most wanted to preserve: the celestial configuration that preceded the flood, the planetary alignment that marked the last great reset, the pattern that would appear again in the sky when the time came for the cycle to complete and the waters to rise once more. If they calculated when that pattern would return, the calculation would be the most important piece of knowledge they possessed, and they would have encoded it carefully, embedded it in numbers that looked like king reigns and astronomical cycles and religious calendars, hidden it in plain sight where it could survive the very catastrophe it predicted. In a research office at the Jet Propulsion Laboratory in Pasadena, an astronomer works late into the evening, her computer screen filled with orbital calculations that trace the paths of planets across centuries. She is modelling the positions of Jupiter and Saturn, tracking when they will appear to meet in the sky as seen from Earth, calculating backward through time to determine when past conjunctions occurred, and forward to predict when future ones will happen. The mathematics is complex but well understood, a straightforward application of Newtonian mechanics refined by centuries of observation. On her desk, propped against a stack of journals, sits a photograph she keeps as a kind of talisman, a clay tablet from the British Museum collection, covered in cuneiform script, containing Babylonian records of Jupiter-Saturn conjunctions observed more than 2,000 years ago. She has compared the ancient observations to her own calculations. They match, not approximately, not within acceptable margins of error, but precisely, the Babylonian scribes recording positions that her computer models confirm with modern precision. The photograph reminds her of something she finds both humbling and unsettling, that the questions she asks about celestial mechanics are the same questions asked by astronomers who lived before the Roman Empire, before classical Greece, before the construction of the pyramids. The sky has not changed, the cycles have not changed, only the tools for calculating them have evolved. And sometimes, looking at that photograph, she wonders whether the ancient astronomers knew something she has not yet rediscovered, whether their obsessive tracking of celestial cycles was driven by a purpose she does not fully understand, whether behind the religious language and mythological framing there was a calculation she has not yet learned how to read. Everything we have examined across the previous chapters points toward a single unified system, a coherent framework in which mathematics, mythology, astronomy, and historical narrative all serve the same underlying purpose. The base 60 mathematics was not chosen for commercial convenience but for astronomical precision, optimized for calculating the cycles and fractions that describe celestial motion. The Sumerian king list was not a garbled memory of impossibly long-lived rulers, but an astronomical timeline encoding cosmic epochs in the language of dynasty, measuring vast spans of time in units of 300–600 years that correspond to celestial cycles. The flood narrative was not merely a cultural memory of a single catastrophic event, but a documentation of cyclical catastrophe, a recognition that the waters had come before and would come again, that destruction and restoration were built into the structure of cosmic time. The astronomical records, tracking Venus and Jupiter and Saturn with obsessive precision, were not idle curiosity about the heavens but data collection for a predictive system, an attempt to identify the patterns that would signal the next transition, the next reset, the next descent of kingship from heaven. Each element makes limited sense in isolation. Together they form something larger, a civilization that understood time as cyclical, that believed catastrophe was calculable, and that devoted enormous resources to the project of determining when the wheel would turn again. The number that emerges most consistently from this synthesis is 432,000. In certain versions of the Sumerian king list, particularly those that expand the reign lengths beyond the more conservative figures in the Weld-Blundell prism, the total pre-flood period adds up to exactly 432,000 years. This is not a random figure. It is a 20 ser, 120 units of 300 years, a number that fits perfectly into the sexagesimal system, and that carries mathematical elegance within the Sumerian framework. But what makes 432,000 truly remarkable is that it appears independently in other ancient traditions with no obvious connection to Mesopotamia. The Hindu concept of the Kali Yuga, the current age of darkness in the vast cosmic cycle of Indian cosmology, is assigned a duration of exactly 432,000 years. The full cycle of 4 yugas, the Mahayuga, lasts 430,000 years, a simple decimal expansion of the same base number. The number appears in Norse mythology, where the warriors in Valhalla number 432,000, and in certain interpretations of Egyptian chronology. Either multiple civilizations independently arrived at the same figure through coincidence, or there was transmission between cultures we have not yet traced, or all of these traditions inherited the number from a common source, older than any of them, a source that calculated cosmic cycles before the flood that separated the ancient world from the world we know. The persistence of 432,000 across unrelated cultures suggests that this number was considered fundamental, key to cosmic chronology, that different peoples preserved even as they forgot why it mattered. Modern science offers unexpected resonance with these ancient calculations, though not in the mystical sense the Sumerians would have understood. The Milankovitch cycles, named for the Serbian mathematician who first calculated them in the early 20th century, describe variations in Earth's orbital parameters that drive long-term climate change. The eccentricity of Earth's orbit varies over a cycle of roughly 100,000 years. The axial tilt oscillates over a period of about 41,000 years. The precession of the equinoxes completes its cycle in approximately 2,520 years. These cycles interact in complex ways, reinforcing each other at certain intervals and cancelling at others, producing the ice ages that have periodically transformed Earth's climate over the past several million years. The timing of these cycles, measured in tens of thousands of years, falls within the same order of magnitude as the Sumerian astronomical numbers. The precession cycle of 2,520 years is remarkably close to the 2,520-year period that some ancient astronomers associated with the rotation of the equinoxes at point through all 12 zodiac constellations. If you multiply 2,520 by 16 2/3, you get 4,2000, suggesting possible mathematical relationships between precessional and larger cycles that ancient observers might have identified, even without understanding the physical mechanisms involved. We do not know whether the Sumerians were aware of Ice Age cycles in any explicit sense, but if their ancestors had survived one such cycle, if memories of a world transformed by rising waters and shifting climates had been passed down through generations, they might have sought to understand the pattern, to calculate when such transformations recurred, to preserve that calculation for descendants who would need the knowledge. The question that presses against everything we have examined is what exactly the Sumerians were counting toward. The king list does not end with the flood. It continues through the post-flood dynasties, through the historical period, through rulers whose existence can be verified by the independent archaeological evidence. The calendars keep running. The astronomical observations keep accumulating. The omen literature keeps growing, adding new correlations between celestial patterns and terrestrial events. If the Sumerians believed they were living within a great cycle, if they understood the flood as a transition point rather than an ending, then they must have had some sense of where they stood within the cycle, how much of it had elapsed and how much remained. The king list gives us a total pre-flood duration of either 241, 200 years or 42,000 years, depending on the version. The flood occurred roughly around 2900 BCE, according to the archaeological evidence, roughly 1400 years ago. If the cycle is 432,000 years long and the flood marked its beginning, we are barely 1% of the way through. If the cycle is shorter, if the SAR unit of 300 years represents a more relevant period, then we are already well into the current phase. Different calculations yield different answers, and we cannot know which calculation the Sumerians considered most significant, but they apparently knew. They apparently had a framework for understanding where they stood in cosmic time, and they apparently considered this knowledge important enough to encode in every system they built, from mathematics to mythology to the alignment of their temples. The uncomfortable arithmetic of cyclical time forces a confrontation with questions we would rather not ask. If catastrophe recurs on calculable intervals, then the next catastrophe has a date, even if we do not know how to read it. If the Sumerians encoded their calculations in the king list and the astronomical records and the mythological narratives, then the answer exists somewhere in the archive, waiting for someone to assemble the pieces correctly. The various proposed cycles, whether 300 years or 2,520 years or 42,000 years, all have implications for the present moment. A 3600-year cycle starting from 2900 BCE would have completed around 700 CE and would be due to complete again around 4300 CE. A precessional cycle starting from 2900 BCE would complete around 23,000 CE. A 432,000-year cycle would extend so far into the future that it seems almost irrelevant to human concerns, but we do not know which cycle mattered most to the Sumerians. We do not know whether they tracked a single master cycle or multiple interlocking cycles. We do not know whether the flood represented the beginning of a new cycle, or a midpoint, or some other significant marker. The knowledge that would answer these questions may exist in tablets we have not yet translated, in patterns we have not yet recognized, in numbers whose significance we have not yet decoded. Consider what you would do if you knew a catastrophic reset was coming, not tomorrow or next year, but at some calculable point in the future, perhaps centuries or millennia away. You would want to preserve knowledge, to ensure that the sciences and technologies necessary for rebuilding civilization would survive. You would encode that knowledge in the most durable forms available. Stone monuments, clay tablets, oral traditions structured as mythology to ensure cultural transmission. You would create mathematical systems that encode their own usage, that teach their methods through their structure, that could be reconstructed by anyone who studied them carefully. You would align your monuments to the stars, creating a reference frame that survives the loss of language, that speaks through geometry rather than words. You would embed your warnings in religious narrative, knowing that sacred stories persist across cultural changes that destroy secular records. You would build ziggurats that double as observatories, ensuring that the watching continues generation after generation, that the data accumulates, that the calculations remain current. You would do exactly what the Sumerians did. Every peculiarity of their civilization, from the mathematical base to the mythological structure to the architectural alignments, makes sense as a survival strategy, as an attempt to transmit crucial knowledge across a catastrophic discontinuity they believed was coming. We have been reading their records as history, but history is about the past. What if they were writing about the future? What if the clay tablets resting in museum archives are not merely records of what happened, but warnings about what will happen again, ticking quietly through the millennia, waiting for someone to calculate the date? In the Bodleian Library at Oxford, among collections of medieval manuscripts that rarely see the light of day, there exists a parchment chart drawn by an English astrologer in the 13th century. The chart maps planetary positions for a particular date, showing where Jupiter and Saturn appeared in the sky relative to the zodiac constellations, calculating when their next conjunction would occur. The astrologer was attempting to predict the fate of kingdoms, following a tradition that held great conjunctions to be omens of political transformation, of the rise and fall of dynasties, of wars and plagues, and the death of kings. In the margins of his chart he has written calculations, and though he uses Arabic numerals that had only recently arrived in Europe through Spanish intermediaries, the underlying mathematics is sexagesimal. He divides his circles into 360 degrees. He measures time in units of 60. He tracks cycles within cycles, wheels turning within wheels, planetary periods that nest inside each other like Russian dolls. The astrologer almost certainly did not know that he was using a mathematical system invented in Mesopotamia 3,000 years before his birth. He would have attributed his methods to Ptolemy, the Alexandrian astronomer, whose Almagest had been translated into Latin a century earlier. But Ptolemy himself had drawn on Babylonian sources, and the Babylonians had inherited from the Sumerians, and so the medieval astrologer in his Oxford study, calculating conjunctions by candlelight, was the unwitting heir to a tradition that stretched back to the clay tablets of Ur and Uruk and Nippur. The knowledge had not disappeared. It had travelled, adapting to new languages and new theologies, changing its clothing while preserving its structure, moving through cultures like water through underground channels, sometimes surfacing and sometimes vanishing from view, but never entirely lost. The Babylonians who conquered and absorbed Sumerian civilization did not discard what they found. They systematized it, expanded it, refined it into the most comprehensive astronomical archive the ancient world would produce. The series known as Enuma Anu Enlil, named for its opening words meaning when the gods Anu and Enlil, comprises roughly 7,000 individual omens derived from celestial observation, a vast encyclopedia of correlations between heavenly events and earthly outcomes. When Venus rises in such a position, expect such a consequence. When the moon is eclipsed in such a manner, the king should take such precautions. When Jupiter enters such a constellation, the harvest will be thus affected. The sheer scale of this compilation represents centuries of accumulated observation, generations of scribes watching the sky and recording what followed, building a database of pattern and prediction that dwarfed anything comparable in the ancient world. Alongside the omen literature, the Babylonians produced systematic star catalogues like the Mul-Apin tablets, which listed the constellations in order of their rising, provided methods for calculating the length of day and night throughout the year, and offered procedures for predicting lunar and planetary positions. This was not superstition dressed as science. This was science dressed as religion, observational astronomy of remarkable sophistication encoded in a framework of divine communication. The Babylonians believed the gods spoke through celestial events, but they also believed those events followed predictable patterns, and they devoted enormous resources to understanding those patterns with mathematical precision. When the Persian Empire under Cyrus conquered Babylon in 539 BCE, the astronomical traditions passed to new inheritors. The Magi, the Zoroastrian priest astronomers who would later appear in Christian nativity narratives following a star to Bethlehem, were deeply versed in Babylonian celestial science. Zoroastrian cosmology already contained a framework of world ages, a vision of history as a cosmic battle between the forces of light and darkness that would progress through distinct periods until a final conflagration and renewal. The Frashokerati, the Making Wonderful, described a culminating transformation in which evil would be defeated, the dead would rise, and the world would be restored to its original perfection. This cyclical eschatology resonated with the Babylonian concept of great cycles and cosmic resets, and the Magi adapted the astronomical methods to their own theological purposes. When Alexander conquered the Persian Empire and Greek culture flooded into the Near East, the astronomical traditions flowed westward. Greek philosophers who travelled to Babylon, who studied with Chaldean astronomers, brought back knowledge that would transform Hellenic thought. Plato, writing in Athens in the 4th century BCE, incorporated cyclical cosmology into his philosophical dialogues in ways that reveal Mesopotamian influence. The famous allegory of the cave, with its prisoners mistaking shadows for reality, is well known. Less remembered is the myth of at the end of the Republic, which describes the structure of the cosmos as a series of nested spheres carrying the planets, a whirl of light spinning around a cosmic spindle, with souls choosing their next lives based on the wisdom they had accumulated. In the Timaeus, Plato goes further, describing the creation of the universe and explicitly discussing cycles of catastrophe. He mentions floods and fires that periodically destroy civilizations, sparing only those who live in mountains or near rivers, and he attributes to Egyptian priests the claim that the Greeks are always children, that their cultural memory extends back only to the most recent catastrophe, while older civilizations preserved records of many such cycles. The Platonic year, the period required for all celestial bodies to return to their original positions, became a fixture of Greek astronomical thought, calculated at various values but often approximating the 25 and 20 years of precessional motion. Plato did not invent these ideas. He received them, filtered through Persian and Babylonian intermediaries, from a tradition that stretched back to the ziggurats of Sumer. The Hindu parallel remains one of the most striking and most difficult to explain. The Yuga system, describing 4 ages through which the cosmos cycles from golden perfection to dark degeneration, employs numbers that echo the Sumerian figures with uncanny precision. The Satya Yuga, the age of truth, lasts 178,000 years. The Treta Yuga lasts 1 to 1,000 years. The Dvapara Yuga lasts 84,000 years. And the Kali Yuga, the dark age in which we currently live according to Hindu tradition, lasts exactly 432,000 years. The full Mahayuga, the complete cycle of 4 ages, totals 420,000 years, and the even vaster Kalpa encompasses 1,000 Mahayugas, periods so immense they dwarf human comprehension. The appearance of 42,000 in Hindu cosmology, identical to the figure that appears in expanded versions of the Sumerian king list, demands explanation. The civilizations of the Indus Valley had contact with Mesopotamia through trade networks that date back to the 3rd millennium BCE. Seals from Harappan sites appear in Sumerian archaeological contexts, and Sumerian texts mention trade with a land called Meluha that scholars identify with the Indus region. Cultural and astronomical knowledge could have travelled along these routes, embedding itself in Indian tradition, where it would be preserved long after the original Sumerian context was forgotten. Alternatively, both traditions might have inherited the number from an even older source, a pre-flood civilization whose astronomical calculations survived the catastrophe in fragmentary form and were reconstructed independently by different successor cultures. Or the parallel could represent independent discovery, different astronomers reaching the same conclusions through observation of the same celestial cycles. None of these explanations is fully satisfying. All of them are possible. The coincidence of the number remains, demanding attention, suggesting connection across distances of space and time that challenge our assumptions about the isolation of ancient cultures. Through the medieval period, the astronomical traditions that had originated in Sumer continued to evolve, passing from Greek into Arabic as Islamic scholars translated and preserved classical texts during the European Dark Ages, then returning to Europe through Spanish and Sicilian intermediaries as Latin translations made the ancient knowledge accessible again. Astrology, which modern sensibilities dismiss as superstition, served during this period as the primary vehicle for preserving astronomical calculation. The astrologers who cast horoscopes for kings and popes were also the astronomers who tracked planetary positions, predicted eclipses, and maintained the mathematical techniques necessary for celestial computation. The Great Conjunction Theory, which held that Jupiter-Saturn alignments marked epochal transitions in human history, kept the Mesopotamian cycle framework alive through centuries when its origins were completely forgotten. Abu Mashar, the 9th century Persian astrologer whose works dominated medieval European practice, calculated historical periods based on conjunctional cycles that traced directly back to Babylonian methods. The Renaissance astrologers who advised rulers across Europe were unknowing, participants in a tradition that began in the scribal schools of ancient Sumer. Their charts and predictions, the distant descendants of clay tablets pressed 4,000 years before. The 19th century decipherment of cuneiform, accomplished through painstaking comparison of multilingual inscriptions and the gradual accumulation of vocabulary and grammar, reopened access to the original sources. For the first time in 2 millennia, scholars could read what the Sumerians and Babylonians had actually written, rather than relying on Greek and Hebrew accounts filtered through centuries of interpretation. The astronomical tablets revealed a precision that startled researchers accustomed to thinking of ancient Mesopotamia as a primitive precursor to classical civilization. The 20th century brought archaeoastronomy, the systematic study of ancient astronomical knowledge, demonstrating that monuments from Stonehenge to the pyramids encoded celestial alignments that required sophisticated observation. The 21st century has added recognition that cyclical patterns are real, that ice ages and climate shifts and orbital variations operate on timescales the ancients might have dimly perceived and attempted to calculate. We are recovering, through science, knowledge that our ancestors encoded in mythology and transmitted through traditions we dismissed as superstition. The numbers in the margins of medieval charts, the 360 degrees in our circles, the 60 minutes in our hours, the great conjunctions that astrologers still track and astronomers still calculate all flow from the same source. Scribes in Mesopotamia, watching the sky, counting the cycles, trying to determine when the wheel would turn again. The knowledge never died. It went underground, flowing through channels we are only now learning to trace. And somewhere in that flow, perhaps, the calculation the Sumerians considered most important, the date they were counting toward, the warning they encoded in every system they built waits to be recognized and understood. The night sky over southern Iraq has not changed in 5,000 years. The same stars that Sumerian priests watched from the summits of ziggurats still wheel overhead in their ancient patterns, Orion striding across the winter darkness, the Pleiades clustering like a handful of scattered jewels, Venus blazing in the pre-dawn east or the post-sunset west, depending on where it stands in its 584-day cycle. The constellations bear different names now, and the languages spoken beneath them have transformed beyond recognition, and the cities that once rose from the river plains have crumbled into mounds that archaeologists call tells, artificial hills made of collapsed mud brick and accumulated debris. But the stars remain, the cycles continue. Whatever the Sumerians were tracking still moves through its appointed courses, indifferent to the rise and fall of the civilizations that have watched it turn. If you stood tonight, in the desert near the ruins of Ur, far from the lights of modern settlement, you would see essentially the same sky that a scribe saw when he climbed the temple stairs to record the position of Jupiter, the same patterns that a priest interpreted as omens of kings and harvests and floods. The mathematics they used to calculate celestial positions would still work. The predictions they made about planetary conjunctions would still come true. Whatever cycle they believed governed the Great Returns would still be cycling, whether anyone remembers how to read it or not. We know certain things with reasonable confidence. We know that the Sumerians possessed astronomical and mathematical knowledge of remarkable sophistication, knowledge that appears in their records without the developmental stages we would expect, knowledge that seems to have arrived complete or to have been reconstructed from fragments of something older. We know that this knowledge was specifically designed for tracking cycles, that the base 60 system optimizes calculation of recurring celestial events, that the SAR unit of 600 years makes sense only in a context where thinking in millennia was normal and necessary. We know that their records show obsessive concern with recurrence and prediction, with knowing not just where celestial bodies are, but when particular configurations will return, with identifying patterns that connect what happens in the heavens to what happens on Earth. We know that the flood narrative preserved in their tablets corresponds to geological evidence of actual catastrophic flooding in the region around 2900 BCE, that the myth was grounded in historical experience, that the Sumerians were documenting rather than fantasizing. We know that similar flood traditions appear across cultures worldwide in ways that resist explanation through coincidence alone. These facts rest on archaeological and textual evidence that has accumulated over more than a century of scholarly work. They are not speculation. They are the foundation on which speculation must build. But beyond this foundation, uncertainty expands in every direction. We do not know where the Sumerian knowledge originally came from, whether it was invented through generations of patient observation in Mesopotamia itself, inherited from a predecessor civilization lost to time, or some combination of indigenous development and received tradition. We do not know what specific event or cycle most concerned them, whether they were tracking the precession of the equinoxes, or the return periods of comets, or conjunctional cycles of planets, or something we have not yet identified in their records. We do not know where we stand in any cycle they might have calculated, whether we are near the beginning or the middle or the end of whatever period they considered significant, whether their mathematics would place us in a time of stability or a time approaching transition. We do not know whether their predictions have any predictive value, whether the correlations they observed between celestial patterns and terrestrial events reflect real causal mechanisms we do not understand or coincidences they elevated to cosmic significance or genuine patterns that science has not yet confirmed. The honest acknowledgement of this uncertainty is not a failure of scholarship. It is an accurate description of where knowledge ends and mystery begins. The Sumerians did not leave us a clear statement of their conclusions. They left us fragments, numbers, patterns, structures that suggest meaning without quite revealing it. The work of interpretation continues and may continue indefinitely without reaching final answers. Yet even without those answers, the impulse behind the record carries its own significance. The Sumerians believed that catastrophe was calculable, that the cycles of destruction and renewal operated according to patterns that observation could identify and mathematics could predict. They believed that knowledge could survive catastrophe, that clay tablets properly stored and copied could outlast the civilizations that created them, that the wisdom of one age could be transmitted to the next across the interruption of flood or fire or conquest. They believed that future generations would need this information, that the calculations they were making and the records they were keeping would matter to people not yet born, that the warnings they encoded would serve descendants they would never meet. The tablets themselves, tens of thousands of them preserved across millennia, are an act of faith in human continuity. Every scribe who pressed stylus into wet clay was betting that someone, somewhere, somewhen would find what he had written and understand it. The fingerprints preserved at the edges of those tablets are the trace of that faith, the physical connection between hands that lived before the pyramids and hands that hold the tablets now in climate-controlled museum archives. The Sumerians were reaching toward us. They are reaching still. The question this raises for us is uncomfortable but perhaps necessary. What knowledge are we preserving for future civilizations? What warnings are we encoding in durable form? Our records are stored in media far more fragile than clay, in digital formats that require functioning technology to access, in languages that depend on continuous cultural transmission to remain comprehensible. If a reset came tomorrow, if some catastrophe disrupted the complex systems that maintain our information infrastructure, what would survive of us? Would future archaeologists digging through our ruins find anything as legible as a clay tablet, anything as durable as a cylinder seal, anything that would communicate our knowledge across the discontinuity? The Sumerians prepared for the interruption they believed was coming. They embedded their crucial calculations in mythology that could survive cultural transformation, in mathematics that encoded in its own methods, in monuments aligned to celestial patterns that would remain meaningful even if the language of their builders was forgotten. We have sent messages into space on spacecraft that will outlast our civilization, golden records encoded with sounds and images of Earth, but we have not prepared with anything like the systematic thoroughness the Sumerians displayed. Perhaps we should. Perhaps the tablets are not merely an archive of ancient thought, but a model for how to think about preservation, about the fragility of knowledge, about the responsibility of those who know something to ensure that the knowing persists. There is a paradox in the uncertainty we have traced through this exploration, a comfort hidden inside the not knowing. The universe operates on scales we cannot fully grasp, cycles so vast that human civilizations are barely a flicker in their duration. The Sumerians understood this. They faced the same immensity we face, the same humbling recognition that individual lives and even entire cultures are brief against the backdrop of cosmic time. And they did not despair. They built, they recorded, they preserved. They watched the stars and pressed their observations into clay and trusted that the watching mattered, that the recording served some purpose, that the clay would find its way to hands that needed what it held. We can accept the same uncertainty. We can acknowledge that we do not know when the next reset will come, do not know what cycles govern the catastrophes that punctuate geological and human history, do not know whether the Sumerian calculations contain warnings we have not yet decoded. And we can still live, still wonder, still question, still watch the same stars that Sumerian priests watched, still feel the same awe at patterns too large for any single perspective to contain. Maybe the Sumerians knew exactly when the next great reset would happen. Maybe their calculations, buried in base 60 mathematics and impossible king lists, contain a date we have not decoded yet, a warning waiting patiently in museum archives for someone to assemble the pieces correctly. Or maybe they only knew what we know, that nothing lasts forever, that catastrophe returns, that memory is fragile, and that the best we can do is press what matters into to clay, align our monuments to the stars, and trust that someone, someday, will find them and understand. The desert wind still moves across Iraq, carrying grains of ancient mud brick into the night sky. And somewhere in a museum archive the tablets wait, patient, geometric, still counting. Perhaps they are counting towards something, perhaps they are counting down, or perhaps they are simply waiting for us to remember what we forgot, that time moves in circles, that catastrophe teaches, and that the hands that pressed those fingerprints into clay 5,000 years ago were reaching toward hands not yet born, reaching toward us, still reaching, and as the stars turn. Overhead in patterns the Sumerians named, as the planets move through cycles they calculated with impossible precision, as the great wheel continues its slow rotation through cosmic time, the question they left us remains open, unanswered, perhaps unanswerable. What were they counting toward? When did they believe the next return would come? And in the silence between the numbers, in the space between what we know and what we have forgotten, the answer waits, patient as clay, old as starlight, still reaching across the millennia toward whoever finally learns to read it.